All right, so now on to cosine, and just remember what we're going to be working on in this one is using the parent function to apply our initial period, for cosine, starting at 0, ending at 2 pi. And we're basically just going to apply the operations for sine and cosine here of this function. So basically in here, we can see that our a, in this case, is going to be 1. So my amplitude, which I'm just going to abbreviate with amplitude, is just going to equal to the absolute value of 1, which is just 1. My period is going to be, again, my 2 pi divided by b, where in case my b in this case is 1. So that would just be, 2 pi over 1, which is just 2 pi. The next thing is I'm going to want to determine my phase shift. And you can see this phase shift, this graph is being shifted pi over 4 to the right. So I'll just write pi over 4 to the right. And then I have my vertical transformation, and that's going to be shifting up 1 unit. Okay, so now based on this information, did I talk about, let's go and talk about the range. So again, remember the range of the initial function or initial period is from -1 to 1. And since this graph is now being shifted up 1 unit, my range is going to be from 0 to 2. And just a reminder, if you want to check your answers here, I have this, I have the link here to bring you up to these examples that you can go ahead and take a look at all of these. So we're looking at this one right here, and you can basically kind of compare it and see how the range is from 0 to 2 right there. So just a reminder, quick reminder that all of these answers you can go ahead and check, with on this link. All right, so let's go ahead and continue. Let's just do a rough sketch, even though I just kind of already showed you that. So it's pi over 4 to the right and being shifted up 1, and then a period still of 2 pi. So basically, again, if here is my initial period, remember for cosine, I'll draw the initial period here. So here's 2 pi, and this would be pi. So, and that'd be pi over 4, pi halves, 3 pi halves. So the graph would look something like this. So that is the initial. That looks bad, horrible actually. Let's try that again. So go down, cross at pi halves, and then come back up. There you go. All right, so that's the rough initial period that I already sketched for cosine. And basically now by applying these operations here, I am going to have the same period, same amplitude. It's just being shifted pi over 4 to the right. So this is at pi halves, this is at pi. This is at pi halves. So being pi over 4 then would just be right there, halfway between 0 and pi halves. And then the graph is also being shifted up 1. So now that'd be at 2, and let's sell that 1. So now the graph is going to start there. And then basically each of these points, that's going to be at 0. So now the graph is going to, let's see, be at pi over 4 over. So just a rough sketch here. Not doing the best, but obviously you can see how that graph is, and I don't want to confuse that. So let's put a little dot there. There's 2. So you can see that it's being shifted over pi over 4 to the right. And my graph looks horrible, but hopefully at least you're getting the idea. It's not, it's not shifting left or right. I got to be careful with that. Of course. Because there's that pi, right? So it's being actually shifted pi over 4 to the right. So it's actually the denominator is going to cross down there a little bit farther down. Okay, so not as bad, but hopefully we'll improve upon that with other graphs. So for the next one, what we're going to do is, again, identify the amplitude. So again, the amplitude is the absolute value of A. So that's absolute value of -3, which is equal to 3. The period is going to be 2 pi divided by b. Now, again, remember that x over 4 is the same thing as 1/4 x. So therefore, my b is 1/4. So I'm going to do 2 pi divided by 1/4. And you can just multiply by the reciprocal, and you would get is 8 pi. Let's go ahead. There's no phase shift. There's no vertical transformation, but we do have a reflection about the x-axis. Okay, so it's kind of important to understand if we're reflecting, here's the parent graph, right? So if we reflect this about the x-axis, then everything's going to be flipped over. So everything really is about the same except for the amplitude. Instead of going up to 1, down to -1, like our initial period, we're now going to go up to 3, down to -3, and it's going to take us all the way to 8 pi to complete a circle. So I'm not going to complete the parent graph here. I'm just going to say, here's 8 pi. So then midway would be 4 pi. And if you want to do like midway for all these, you could do your x scale and figure that out. Okay, and there's going to be -3, and this would be +3. So we can just kind of like change the scale, looking at this. But again, it's being reflected. So now it's going to be something like this, cross, up, cross, and then go down. So that's what the initial period would look like with the transformations. All right, y equals 3/2 cosine. Oh, did I talk about the range? I did not. I forgot about the range. So the range in this case is going to be, obviously you can see that the lowest the graph goes is -3, and the highest it goes is going to be +3. All right, so for the next one, now we have a as a fraction, and you're kind of like, that's kind of like interesting. But again, it's not going to really affect anything because the amplitude is the absolute value of a. So absolute value of 3/2 is just equal to 3/2. Now the period is something we actually want to, actually not the period, but the phase shift is something we're going to want to be interested in. And even the period, like it's not even understood what the, b is. So remember our initial case here is we want to have this written as b times x minus c notation. And right now it's not written in that format. So what I'm going to do is I'm just going to rewrite this as -x plus pi, right? Just write the x in front of the pi. I always have to write x. And then you can see here my b is -1. So I factor out the -1 and I'm left with x minus pi. So therefore we can see b is our -1. However, that's not going to affect the period because the period is a distance. So it's still always going to be positive. So we just write the period. And that's just going to be 2 pi divided by 1 in this case, or 2 pi. Now the phase shift is important because, when you have this factored out, there's a couple of different ways you can look at it. When you look at the phase shift from this point, you can see that obviously it's going to be pi units to the right. But some students, get confused with this rearranging. So again, you could also look at this by using the initial period. If the initial period starts at 0, and then here is my new function, all you got to do is just solve for x by adding x to the other side. You could say x is, instead of the function starting at 0, like the parent graph, it now starts at pi, meaning the graph is being shifted pi units to the right. So you can either use either technique. I prefer the factoring out technique and rearranging. However, you can always set it equal to 0, which is the start of the initial period, and then identify the transformations that way. There is no vertical transformation and there is no shift. The range, though, is still, you got to look at the amplitude. You can see that now, since it's at 3/2, the graph is going as high as 3/2 and as low as 3/2. So we'll start with the low up to the high. Okay, and now last but not least is we have the cosine graph, which we have double negative. We have a reflection about the x-axis, reflection up the y-axis, and then a horizontal shift 2 units down. The nice thing is my amplitude is going to be easy to calculate, which is just 1. My period, again, is just 1, so that's, or b is 1, so that's going to be easy to calculate. So that's 2 pi. Do not have a phase shift, so not going to worry about it. My vertical translation is going to be equal to down 2. All right, and then did I write, oops, I forgot to write in my reflection here. You can see that there's a reflection about the y-axis, so let's write that in there. Oh, why didn't I sketch the graph of that? I could throw an A in there too. Let's go ahead and sketch the graph here. So we have a reflection about the y-axis. Now, the nice thing about the cosine function is it's an even function. So, just like a quadratic, if you take a quadratic and reflect it about the y-axis, you're going to have the same quadratic. If you take the cosine graph and reflect it about the y-axis, you're going to have the same graph. So even though we want to note that it has a reflection about the y-axis, it's not actually going to be affecting the graph at all. So therefore, we can just focus here on my phase shift. and my amplitude. So my amplitude is going to give us 3 halves and a negative 3 halves as my max and my mins. And then rather the graph starting at 0, my graph is now going to start at pi. And then again, the period is still 2 pi. So pi plus 2 pi is going to take us all the way to, let's just go to 3 pi. Okay, and the reflection about the x or y-axis, again, as I mentioned, is not really going to change anything. Now, if you need to figure out what these points would be, I just like to do a rough sketch. Obviously, what you could do is go ahead and divide this, your period, to find your x scale. If you needed to figure out like where does this cross, where does this cross, and where does that cross, you just take the period, divide it by 4, and that gives you your what we call our x scale again. So therefore, that would be pi halves. So from here to here, add pi halves. From here to here, add another pi halves, and then you could figure out those points. But that's not really a big concern of mine as far as students being able to graph these accurately. I just want to make sure you guys can understand the initial sketch of the graph. All right, so let's go and take a look at the graph here. So we have the reflect x-axis, x, and the y-axis. And the range, so if the range is at -1 to 1 and it's being shifted down 2, now it's going to go from -3 to -1. So let's go ahead and sketch a graph here. Now, the reflection about the x-axis is not doing anything, but we still have to include the reflection of the y-axis. So therefore, the graph is going to be flipped. We're going to go down from, let's say, -3 to -1. And rather than it going from here, it's now going to kind of come up, and then the period is again 2 pi. So let's kind of do, here's pi, and let's have the endpoint right there. So the graph would look something like this. Not like that. Let's do it again. There's no shift, right? Yeah. So the graph still starts at 0, and then it'd have its maximum value at 1. And then come down from there. Okay, and again, all these answers here have a nice little link for you, so we can go and check. And I'm just kind of curious on my last one, see how that did. And you can see that was exactly what I had. I had my initial period from there to there. So you can see, and it goes, oops, from there to there to there. So I had the maximum value at -1, and there you go from 0 to 3. So all the answers, again, if you want to check, they're all on this link here for you to go ahead and verify your answers. But that was for the sine and cosine. Now we're going to get into a completely different parent graph, which is going to be represented by the tangent graph. So let's go ahead and see how the tangent graph is now going to change from the sine and cosine.